Welcome to the 19th episode of Byte-Sized JavaScript. The previous episode was mostly about promises, and in this episode we'll dive deeper into promises, and along with that we'll also look into other control flow patterns and practices as well. And before we move on, I want to grab your attention to something. Continuation passing style, or CPS, which also is a fancier way of saying that we are using callbacks, is a form of IOC, which is inversion of control. And similarly, promises is also a way of inverting the control flow itself. So let me explain why. Because when you use a continuation instead of making a blocking request and waiting for the response to come, you are essentially delegating the control flow to another module, and then that module taps into your main routine using the callback and dispatches a message at a later point in time, and eventually you react to that message inside your callback. Therefore, we are inverting the regular flow of code here. Instead of our main routine calling subroutines waiting for them to respond, other modules are calling into our main routine via callbacks. And this behavior is one of the many definitions of the principle called inversion of control, or IOC. So inversion of control, or IOC, is also known as the Hollywood principle because instead of directly calling a function, you are waiting for a callback. So it is similar to saying, "Don't call us, we'll call you back." So let's move on. If you compare the continuation passing style of doing things to promises, you'll see that the promise one is arguably easier to follow. Though, to be honest, a well-written CPS code will not be that difficult to handle either. However, aside from the eye-candiness or the ease of managing the code, promises have other advantages that make them uniquely appealing as well. For example, for handling error cases and exceptions, a promise-based approach will provide a much cleaner solution than a callback-based one. When you look at this example, the difference is not that eminent, but if you have many of these requests that depend on each other in a complex way, then you'll see the benefit of using promises more prominently. For example, let's try to make multiple requests. When using promises, this will be as simple as chaining a bunch of promises together with then methods. I don't know you, and this looks much readable to me than a callback-based solution. And when we call it, you'll see that we get the responses in order as expected. Now we'll take it one step further and try to do the same thing with async await. At the time of this recording, async await is a stage 3 TC39 proposal, which also means that most probably you'll see it standardized in the next version of JavaScript. For the async await to work, we'll first need to mark the function as async. So in this async function, we are asynchronously returning a promise, and we'll create another async function called run and immediately call it. And inside this run function, we'll call fetch until success functions and cache the responses in different variables. Now here's the trick. We await for the promise that the async function fetch until success returns, which will halt the execution, wait for the promise to resolve, and then assign the resolution value to the variable and continue the execution from where it's left off. This will result in running asynchronous code in a pretty much synchronous looking manner. For that to work though, you'll either need to use a transpiler like Babel, or if you are using a recent version of Node.js, you'll have to use --harmony async await flag to enable that functionality. You can even put this code block inside a try catch, and if a promise gets rejected, you'll catch the rejection inside this catch block, as if we were dealing with a synchronous program. So using async await flattens your code and makes it as if it was synchronous, which will make it much easier to reason about. Overall, promises is an improvement over continuation passing style, and async await is kind of an improvement over promises. Next and finally, we'll look into observables, though before that, let's try to look at one more async API, which is generators. A generator is a function that will return an iterator interface. It is a better browser support than async await right now, though as you'll see soon, it's a bit harder to use than async await, and it requires some more boilerplate code to keep things together in good shape. To define a generator, you just define a regular function, but additionally you put an asterisk to the left of it. Now this function is running forever in an infinite loop, and it's randomly incrementing this seed value. And let's assume that we want to tap into this loop and yield values at every single iteration. That's where generators come in handy. So how do we yield a value? Well, by using this yield keyword. So the generator returns an iterator which has a next method, And the first time we call the iterator, the flow goes into the yield keyword, executes the statement here, and then yields the value of the statement and stops there. If we want to assign that value to x, we need to pass that value using the next function. And after that, the execution will continue from where we left off. We'll loop this loop and stop at this yield statement once again after calculating this statement. In this next iteration, we are not using a value, so x will be essentially undefined, which will make the seed equal to nan, which is not a number. And once we compute this statement, we'll get some garbage value out of it. And now, even though we push a number to x at this time, and x will be 20, and since seed is not a number, adding 20 to not a number will still yield not a number. And if you want, you can also use the throw method of the iterator interface to raise an error. Now let's write something practical, like replicating our former Ajax retry example by using generators. So what we have is this main routine, which is a generator, and we create an iterator by calling main, and once we get a response and our promise resolves, we send the response to the variables by calling this next method of the iterator. So when we run this code, we get what we expect, receiving the results in the exact order that we called them. And there are libraries like co or Bluebird's coroutine function that streamlines the process and hides the boilerplate code from your eyes to make life easier for you. Finally, let's look into observables. Observables are not something that you can find natively in JavaScript, though the concept is gaining some traction and some popularity among the community, so I thought it's worth a mention. After all, using observables teaches you a different way of looking into your data. Observables take a series of events that spread across time, and then they transform those events as if they happen linearly in the same space. So I feel it's just like a transformation between a frequency domain and a time domain. Let's go back to our code anyways. We'll again use our fetchUntilSuccess method, which returns a promise. And to use the observable API, we'll need a library that supports the observable interface. And since the most popular and well-supported observable library is RxJS at the moment, I'll just go with it. I'll first install RxJS with npm, and I won't be covering how RxJS works or the philosophy behind observables, because understanding observables requires a dedicated session on its own. So for more information, you can visit these links that you see here. And if you want to start playing with observables, these are really nice pointers to get your hands dirty, so to speak. So if you want a fresh starter on reactive programming, this tutorial by Jafar Hussein and this gist by Andreas Saltz are great points to start. So after requiring Rx and observable and the from promise, we'll create 3 different streams from our 3 different Ajax requests. I'll also paste this former await-based implementation to compare and contrast. So creating a chain of observables, as you see here, is nothing but creating an execution plan. We'll run the first stream, and once we get the data out of it, we'll log it and then map it to the second stream. And then once we get data, we'll log it and map it to the third stream, which will be essentially doing the same thing as the above async await-based example. One thing that you should know about streams is that streams are lazy, so this chain of functions only create an execution plan, and nothing will happen unless we subscribe to it. So let's subscribe to this chain and see what happens. So when we run this execution plan, we'll get a similar result as the former examples, and we'll get the responses to our requests in order. One subtle advantage of using streams is that we are sending those requests in parallel and waiting for them to merge in order, so we'll be saving some processing time instead of sending them back to back. And more importantly, instead of calling functions imperatively, we are using a more declarative code. What I mean is, once you know how this flat map functions and how this subscribe function works, then there's no magic in this code. You can read and understand it as if it was a plain English text. As I said, there is a lot more to cover than this to properly understand how observables work and how streams are used in functional reactive programming, and this is just a little sneak peek to provoke your curiosity and attention a little bit. And that's the end of our episode. To sum up, in this episode we have looked into different ways of programming asynchronous control flows in JavaScript, which were continuation passing style, and promises, and generators and iterators, and async await. We even looked into observables and observable streams and got a taste of doing functional reactive programming. In the next episode, instead of theory, we'll do some practical applications and we'll be designing a responsive web interface which will eventually become the UI of Byte-Sized.tv. I bet it will be fun. So until then, may the source be with you.